Now to do this question, what I would do is draw a sketch. We're told that this particle P moves on the x-axis, so have our x-axis here, and we'll just put the particle P, say, somewhere there. And the acceleration of P at time t being greater than or equal to 0, is 3t plus 5 meters per second. So I'll draw my acceleration arrow and put that in as 3t plus 5 meters per second. And we're told that when t equals 0, the velocity of P is 2 meters per second in the positive sense, in the positive x direction. So let's suppose the particle's somewhere over here then when t equals 0. So we know that at this point it is moving at 2 meters per second. So we'll just put that arrow in that direction, and I'll also put the fact that when it was here t was equal to 0. We're also told that when t equals big T, it's at another particular point, don't know where it is, but t equals t, say here, it's moving with a velocity of 6 meters per second in the positive x direction. So therefore, at this point here, it's moving in this direction at 6 meters per second. And we've got to find this value of t, so how are we going to do this? Well, what we should know is, or what we're given anyway, is that this acceleration, let's start with that. We know that the acceleration is 3t plus 5. And we've got to work backwards. We've got to work backwards from here. We know that because the acceleration is not constant, then this is given by dv by dt, the rate of change of velocity with respect to time, gives us the acceleration. So dv by dt equals 3t plus 5. And to get what v is, we need to integrate with respect to t. So we end up with v equaling the integral of all of 3t plus 5 with respect to t. Now, if you integrate this with respect to t, remember just add 1 to the power and divide by the new power, you're going to get 3t squared over 2, and for the constant that will just be 5t. But don't forget the constant of integration, plus c, say. Obviously you can use any letter you like. So therefore we have v equals this general result. Now we need to work out what this constant c is. And to do that, we can look at, say, this condition here, often referred to as a boundary condition. We know that when t is equal to 0, the velocity v is equal to 2. And also note that it is in the positive sense. The positive sense is taken towards the right. Obviously, if this had been in the other direction, I'd have had to say that v equals minus 2. But for this question, anyway, v equals 2. And we can substitute this into this equation here. If we do that, it will allow us to work out what c is. So when t equals 0, v equals 2, that will therefore give us 2 equals, well, this term is going to be 0. This term will be 0 when you substitute t equals 0 in, and that just leaves us with c. So c equals 2. And we can substitute that back into this equation, and therefore we have v equals 3t squared over 2 plus 5t plus that constant of integration, which is 2. Now that we've got this, we can work out what t is, because we know that when t equals big T, we know that the velocity v equals positive 6. So if we substitute this into that equation, we have 6 equals 3, and then big T squared over 2 plus 5 big T plus 2. And we can multiply throughout by 2, and therefore we're going to get 12 equals 3t squared plus 10t plus 4. And we've got a quadratic equation here where we need to rearrange this, make it equal to 0. So if I take 12 from both sides, you're going to get 3t squared plus 10t, and 4 minus 12 is going to give us minus 8, and that equals 0. So all we need to do now is just try and factorize this quadratic. And if we do, it's going to go into two brackets, and those two brackets are going to be 3t minus 2, we can just squeeze it in here, and t plus 4, and that's going to equal 0. So that means that each of these two factors could equal 0, so 3t minus 2 could equal 0, and that would therefore lead to t equaling 2/3. Or if the other factor, t plus 4, equals 0, then clearly t would equal minus 4. But what we know is that t has to be greater than 0. Greater than or equal to 0 really, but so, well, that means that obviously t can't be minus 4. It's got to be 2/3. So therefore t equals 2/3. 2/3 of a second. Okay, so I hope that's given you some idea then how you can go about that question.